In this video, we'll be graphing polynomial functions. Our strategy for graphing polynomial functions, we want to start by determining the end behavior. We'll use the degree of the polynomial and the sign of the leading coefficient to determine the end behavior. Next, we want to find the zeros of the polynomial and their multiplicities. We'll also make note of whether our graph is going to either kiss, straight cross, or wiggle cross at the x-axis. Then we want to identify the y-intercepts. We'll plot all of our intercepts, the x-intercepts we get from the 0 and the y-intercept we found in step 3. Then we'll use the end behavior and the multiplicity of the zeros to sketch the curve in a general sense. So let's graph f of x equals x minus 2 times x minus 1 squared times x plus 3 cubed. We'll start by determining the end behavior. First, we need to identify the degree of the polynomial. Since our polynomial is in factored form, we're going to add the exponents together to determine the degree. Now, don't forget that this factor of x minus 2 has degree 1. So 1 plus 2 plus 3, this polynomial function has degree 6. Looking to the leading coefficient, we got like an invisible positive 1 out here in front. So we have a positive leading coefficient. Putting those two together, even degree, positive leading coefficient, our end behavior is going to look like positive x squared, which means that it's going to enter from the top and exit out the top as well. Now we want to move on to our zeros. To identify the zeros, we set our polynomial equal to 0. If it's not in factored form, we need to get it in factored form. This one's already factored for us. So each factor is going to produce a 0. The 0 that goes with our factor of x minus 2 is positive 2. It has a multiplicity of 1. So what does a graph do at the x-axis when we have a multiplicity of 1? Well, 1 is an odd number, so I know it's going to cross. And since that odd number is 1, we're going to straight cross at x equals 2. Moving on to our next factor of x minus 1. The 0 is positive 1. It has a multiplicity of 2. That's an even number, so our graph is going to kiss the x-axis at x equals 1. And then our third factor, x plus 1, gives us a 0 of negative 1. It has a multiplicity of 3. That's odd, so we know it's going to cross. But since it is an odd degree higher than 1, it's going to wiggle cross when it crosses. We also want to find the y-intercept. To find any y-intercept ever in our life, we let x be equal to 0 and solve for y. So that'll be y equals 0 minus 2 times 0 minus 1 squared times 0 plus 1 cubed. So It's negative 2 times negative 1 squared times positive 1 cubed. It's negative 2 times positive 1 times positive 1. We get negative 2. Remember, since it's a y-intercept, you want to be sure to rewrite it as an ordered pair, 0, negative 2. We have found all of our intercepts, so now we want to plot those intercepts on our graph. We have one at x equals 2, x equals 1, x equals negative 1, and those are our zeros, right? We're taking them and plotting them as x-intercepts. And then we have our y-intercept of 0, negative 2. Once we have those points plotted, we're going to use our end behavior and what we've noted here about how our graph is going to behave at our corresponding x-intercepts to draw in the graph. Our end behavior tells us that we start by coming in from the top. I'm going to start by coming in from the top, and I approach my first x-intercept. Now, before I get too close to this x-intercept, I want to refer up here to see what I'm going to do. These zeros are not in ascending order, so make sure you're actually looking and don't just straight cross kiss wiggle cross. The first zero that we're approaching is negative 1. We need to wiggle cross the x-axis. So there's my wiggle. I know that the y-intercept is a point on my graph, so my graph has to go through that y-intercept. Now, how far should it go down? We'll learn that in calculus. In this course, we're just doing our graphs in a general sense. So make sure that you loop down and hit that y-intercept, and then we need to come up to the next point that we know is on our graph, which is 1, 0. I see from my list above that at the 0 of 1, I'm supposed to just kiss the x-axis. So we're going to come up and just touch that point and then go back down. How far? About that far. Answers will vary. And then we have to approach our next 0, which is at 2. And I see at 2, I'm supposed to straight cross at the x-axis. There is not another 0 for me to come back to, so my graph is going to continue up. Does that support the end behavior we predicted in the beginning that should be in the top, out the top? Yes, it does. There's the graph of our polynomial function. I will not be asking for domain or range on these graphs. The domain of all polynomial functions is negative infinity to positive infinity, but the range we can't really do because we're just graphing them in a general sense. Let's try another one. Let's graph f of x equals negative 3x to the 5th times x plus 2 cubed times x minus 5 squared times x plus 4 squared times x minus 3. Let's start with the end behavior. We need to identify the degree. We're in factored form, so we're going to add up all of our exponents. 5 plus 3 plus 2 plus 2 plus 1. That gives us a degree of 13. This time, our leading coefficient is negative. We'll put those things together to identify our end behavior. We have an odd degree with a negative leading coefficient. So that's going to behave like a line with a negative slope. So it's going to come in the top and out the bottom. There's our end behavior. Next, we want to identify our zeros. We set our polynomial equal to 0. If it's not in factored form, we need to get it in factored form. Lucky for us, this is in factored form. Each factor is going to give us a 0. So starting here with our first factor, negative 3x to the 5th. This is going to give us a 0 of 0. A lot of times people make mistakes when we have a monomial factor. A monomial factor is always going to give us a 0 of 0. It has multiplicity 5. 5 is odd, so I know it's going to cross. And 5 is a number greater than 1, so this is going to be a wiggle cross. Moving on to our next factor, x plus 2. This gives a 0 of negative 2. It has multiplicity 3. That's an odd number, so I know it's going to cross. And it's an odd number greater than 1, so this is another wiggle cross. Our next factor is x minus 5. This gives us a 0 of positive 5. Its multiplicity is 2, which is an even number. So our graph is just going to kiss the x-axis there. Our next factor is x plus 4. This gives a 0 of negative 4. It has a multiplicity of 2. That multiplicity is even, so we're going to kiss the x-axis at negative 4. And then our last factor, x minus 3. This gives a 0 of positive 3. It has a multiplicity of 1. 1 is odd, so we know we're going to cross the x-axis. And since that odd number is exactly 1, we're going to straight cross at x equals 3. We also need to find the y-intercept before we can start graphing. To find the y-intercept, we let x be equal to 0 and solve for y. Notice that out in front we have multiplication by 0. Well, what happens when we multiply anything by 0? It turns into 0. So this whole thing gets wiped out because of that multiplication by 0 in front. We get y equals 0, making our y-intercept 0, 0. Note that if you have a 0 of 0 up here, your y-intercept is always going to be the origin. If you get a y-intercept of 0, 5,000, you've made a mistake. You probably forgot to multiply by that 0 out in front. So let's plot all of these intercepts. 0, negative 2, 5, negative 4, and +3. Our end behavior tells us we're going to start by coming in from the top. And as I approach my first x-intercept, I'm going to take a look to see what I'm supposed to do, cross or kiss the x-axis. That first x-intercept is at -4, so I see that we're supposed to just kiss the x-axis. So we just kiss the x-axis, go up about that far, and then we start approaching our next x-intercept. Our next x-intercept is at -2. We need to wiggle cross here. There we go. Go down. Approaching our next x-intercept at the origin, I see it's 0. Again, we're supposed to wiggle cross. Coming back down to our next x-intercept, which is happening at 3. At 3, we've noted that we're supposed to straight cross. And then we come back up to our last x-intercept happening at 5. And at 5, we're supposed to just kiss the x-axis and go back in the direction we came. There's not another x-intercept for us to go to, so our graph continues in this direction. Take a look at the end behavior you stated that you were supposed to have in the beginning. Does our graph support that end behavior in the top, out the bottom? It sure does. Here's the graph of our polynomial function.